Our next speaker is Avik Sengupta. Avik Sengupta is the VP of Engineering at Julia Hub, where he is responsible for building their cloud compute and simulation platform. He is a contributor to Julia and maintainer of several Julia packages, as well as the author of Julia High Performance. Avik sir has previously created complex trading systems for the world's leading investment banks.
This is connected, but it's not showing up there. This is connected,
Yes.
but that's showing something else. That's not mine.
Exactly.
That's not mine.
So this image is not from your laptop?
No, no. It is nice, but not mine.
Northern Lights, no?
Yeah.
I'm a geomagnetician.
So maybe it's yours, but not mine. It's coming from somewhere else. Also, it says 427, so that's not mine either.
Could you unplug and plug again?
My computer has an external display connected, so
Could you unplug it and plug it again?
yeah.
I just
Yeah.
experimenta este. Que às vezes
No, this has a second screen, so this is connected to something, but that's not.
it is.
É assim, eu ali estou a recebê-lo. O que está no coisa, no ecrã.
I did test it.
É, o projetor é. Ele está a ler o dele. Muda aí HDMI 1, acho eu, 2, vê lá. Ok.
Yeah.
Yeah. Wait. Isso é um. Agora um bocadinho.
Yes.
Ok.
That is mine,
Ok.
I think. Yes. Thank you. There we go. Thank you for inviting me. Lovely place, lovely day. And my name is Avik Sengupta. I work for Julia Hub. I've been with Julia Hub for a while now. And today I'll talk about using Julia, deploying Julia to other people, right? Other machines, other people, other places. So hopefully, it'll be something that people care about. A little bit about why, to give you a background on some of the things I will say. It comes from my experience writing Julia for the last 10, 12 years. And I say this not to, brag, but to say that many of the things that I'll talk about today is changed over the last 10 years, right? So when we started, there was a lot of things I talked about didn't exist. Maybe even 5 years ago, if I would have done this talk, it would have looked very different. So things keep changing. Thank you. So yeah. So among the topics that I'll talk about today, we'll talk about packaging, how to package Julia code to ship to other people. We'll talk about sysimages and therefore package compiler.jl. I'll briefly touch about Julia C, and throughout my talk, I'll mention sort of caveats, tips, tricks, stuff that we have learned that makes little things that make a big difference in when you are shipping Julia to production machines, really. So the first thing I wanted to mention is that when we say deploying Julia, it means different things to different people, right? You could be deploying to local clusters. You could be deploying to AWS. You could be deploying to your colleagues' workstations. You could be deploying different things. You could be deploying batch processes that are run on demand, that somebody runs a simulation on that takes an hour or 6 hours or 2 days. You could be developing web services that are servicing requests from public customers. You could be deploying a desktop UI, right? And that's possible in Julia. Imagine that. You could be deploying open source code. You could be deploying internal code within your organization. You could be deploying building commercial projects that you send an installer to your customers to run, right? And all of these have different requirements, different needs. And so I think one of the primary messages I want to do today is there are many things you can do. Try to find the simplest thing that solves your problem, right? A lot of discussion around deploying in Julia will talk about, package compiler or sysimages or even Julia C today. But do you really need it? Maybe not. So think about that. So given all this variety of users, I want to sort of abstract it out into the topics that I'll speak about for the next few minutes. And the way I look at deployment is running code in a machine that you don't own, that you haven't developed on, right? That's I think the key sort of differentiator that you need to think about. And the reason why you need to think about that is that every piece of code that you write always has implicit dependencies and assumptions about where it was developed and how it was run. So certainly obvious things like operating systems, but also the instruction sets, not just ARM versus x86, but even in x86, the instruction sets, the actual CPU features that you have. The libraries that you depend on, right? And there are multiple layers to that, to library dependencies. And we'll see some of that as we go along. Even the configuration files, right? The data sets that you depend on. And you have to think about all of these things as you deploy, right? And the important thing is to sort of enumerate them, have an answer to each of these problems as you are deploying, right? So the simplest thing that you could possibly do, of course, is write your code in a Julia file, a .jl file, and email it to somebody, right? And that works, right? And I'm sure a lot of you have done that in the past as you have written Julia code. The problem, of course, is that the user needs Julia installed, but also the user needs all the Julia dependencies installed. And that gets to be the biggest problem, right? Do they have the correct version of http.jl or and that's a big problem that you need to solve, right? So this solution of emailing Julia files works, but only for simple code for somebody that your colleague who can walk over and debug together. That's the use case where that'll work. But very soon it falls apart, right? So the next thing that you can do, and this is probably one of the widest use cases that you can do, is to not just send your source code, but also to send a project and a manifest with it, right? So every Julia package comes with a project toml, which, for a package, you should check it in to Git, obviously. I would recommend that for applications, so for the final thing that the user runs, you also check in the manifest, right? For libraries, you shouldn't check in the manifest, but for end user applications, you should check in the manifest. And given a project and a manifest, you are guaranteed that your user has the same versions of dependencies, right? Of Julia packages as dependencies. And so that gives a much greater guarantee that the code will run successfully. The trouble, of course, is that the user needs to still install the correct version of Julia. And you can, maybe a minor patch version doesn't matter, but something that you have tested with Julia 112 certainly won't run on another machine with Julia 111, right? There is some functionality in JuliaEO that's coming that will help with that, where JuliaEO can actually read the version from a manifest and then run the correct version of Julia for you, right? And that'll, help in this regard, right? One of the big advantages of sending up the source code with the project and the manifest is that you don't need to worry about operating systems, right? The same package will work for Mac, Linux, or Windows, and the user will just instantiate it, right? One downside is, of course, you're now having to track multiple files, right? You have to zip up your source code, the project toml, manifest toml, put them into version control and all of that. But in 113, actually, you can store a project toml and its manifest within a source code. And that's, not in 112 yet, but in 113, that'll, this idea of just sending out source file with a project embedded in it will actually start working from 113. So I think this, the simplest way of sharing Julia code, which is Julia source code with a project and a manifest, actually probably works in a lot of cases, right? So try this first before doing everything else that I'm talking about for the rest of this talk, right? Right. One recommendation that I always say is that if you're writing private code, unless you are one developer installing on one machine, always create a registry for your organization, for your team. It's not very difficult. It's just a Git library, a Git repository. There are tools that can help you with it. Local registry works pretty well. For larger companies, obviously, JuliaHub sells a solution, but for reasonable sized teams, you don't need any of that. Local registry is really good. All the tooling that General uses is available open source, so you can use sort of validations that General registry does. You can do it for your private registry, and it helps immensely in keeping track of what versions you are using. Otherwise, you very easily just lose track of what version which machine has, right? So always use a registry. If you're doing this on HPC clusters, you have a few extra considerations that you should think about. First is that, obviously you need a depot that all your nodes can use, right? So they should be picking up the code and the compiled code from a single place. So you should set up a depot to a shared file system. Typically, shared file systems are slow on clusters, so try to find the fastest one, maybe a temp. Sometimes the temp shared systems are faster than home directories, so try to use that. The important thing on a large cluster is that you should always precompile before you run your job. Because we've often seen that you run on 1,000 node, all those 1,000 nodes start compiling your code simultaneously, and then they are writing to a shared depot, everything just breaks, right? If you can precompile on a login node and then run your job, there's a Julia command line option called minus compile module strict, which will fail unless everything is precompiled already, right? So any distributed job you start, if you start with this compile module strict, then you are guaranteed that you have precompiled it before the job start. Otherwise, the job fails. And that's very useful because otherwise, as I said, if 1,000 nodes start compiling Julia code simultaneously, you don't want to spend the electricity cost for that, really. That's terrible, right? If your cluster has heterogeneous nodes, you should worry about the CPU target that you set for precompilation. So you need to, and we'll talk a little bit more about that. And the final thing on a large cluster is, of course, MPI config, which I have no idea about, but you should ask somebody how to set it. And that's something that is probably one of the most complicated things that you will do on a cluster running Julia code, right? Right. Often, you will package your code into a Docker container, and that's very useful. There are public Julia Docker images that are available, which are pretty useful. You should always build on top of that. The important thing, again, is to precompile during Docker build time, right? Which means you need internet access during Docker build time. You need to worry about what machine you're doing your Docker build, because, again, CPU targets matter. So, if the machine that you're doing your Docker build is not the machine on which you will run things, you need to set your CPU target. This is sort of the default CPU target that works across all machines, so use that. On Docker, one of the things that happens is that Julia's garbage collector figures out how much memory is there on the machine and decides when to run, depending on how much memory there is in the machine, right? It doesn't only look at the memory that your program is using, it also looks at the memory that is available on the machine, right? If you're running Docker on a larger host, then Julia looks at the memory of the host, not of your Docker container, right? And so you can mitigate that by setting a heap size, saying, Julia should only use a certain amount of heap, which is what your Docker container is set to, rather than the host memory, right? Similarly, your Docker container will have a number of virtual CPUs that are different from the host. And so you should also set the thread limits correctly when you're running code inside Docker, right? An aside on precompile workload, I've talked a couple of times about, the fact that you should use precompile. Realize that Julia precompiles code that only runs at compile time, right? So that the code that is at the top level of your module, that is the only code that Julia will precompile. So if you have a function that takes a long time to compile and that doesn't run when the compilation step happens, that function won't be compiled. And then when you run it, it'll compile it and it'll take 30 seconds and you'll be back where you started, even though you have precompiled it. So think about your precompile workloads, and there are tools to help you do that, manage that. There's precompile tools, or you can just manually put those function calls at the top level with some dummy data, and that works as well. But think about that as you are, packaging things. Now, so all of this was, just ship your code, ship source code, precompile at build time, and off you go, right? Sometimes that's not enough, and sometimes you will hear people talk about system images. A system image is basically a snapshot of memory of a running Julia session. So it contains compiled code, native compiled code, and it loads faster than, loading a PKG image or a standard precompiled image, right? Custom sys images basically solve the latency, the compile time latency, the first run latency. So for example, modeling toolkit on my machine takes maybe 5 to 10 minutes to precompile. And even after precompiling, the first using for modeling toolkit can take anywhere between 3 to 10 to maybe sometimes 30 seconds, right? Even after precompiling. So sysimages solves this problem. And to build sysimages, there's a tool called packagecompiler.jl, which does that for you essentially. That's all that it does. So it's a Julia package, you install it, you say using package compiler, and then it has a function called create sysimage, right? So here I'm creating a sysimage with the modeling toolkit and JLMaki, which are two of the Julia packages which probably have the longest compile times. And then when you load that sysimage using this -- sysimage command line flag to Julia, Julia loads up as it normally does, and then using modeling toolkit now is pretty much immediate, right? And that's basically what you get by using sysimages. that your first run latency is significantly reduced. But it's not free, right? It does reduce compile time latency. But do you really need to reduce compile time latency? In many use cases, you don't care about first run latency. But in cases where you do, it helps a lot. It still needs a C compiler on your build machine. On Windows, it automatically installs it, so that's easy. You still need the same version of Julia to load it that you used to create it. You need to download artifacts. So, you need all. So if you have, like Modeling Toolkit has the solvers have Fortran code that are, compiled into DLLs or SOs. You need to somehow get that as well, right? You don't really need the sources, but given the sysimage, if you are trying to do any package operations, you're trying to add more packages on top of your sysimage, you will still need the sources for the packages that you build. So if you are, creating a sysimage from proprietary code, and that, sort of obfuscates your code a little bit, that works. But if you want your user to add a new package on top of your sysimage, you need to think about what you can do. The biggest problem is with a sysimage is it takes a long time to build. It takes 20, 30, maybe hours to build large sysimages. And it creates humongous files, right? So, 2 GB is very easy. There's a 2 GB sysimage limit in Windows in Julia. There used to be a 4 GB limit on Linux. Maybe that's been fixed, I don't remember. But, you hit these limits very quickly where those sysimages are really, really big. So there is a downside to using sysimages, even though, you solve the package everything together problem and you solve the latency problem, right? One of the additional things you can do with a package compiler is to bundle everything, right? As I said, with a standard sysimage, you need the Julia installed, you need the artifacts, so you need all your native dependencies. But package compiler also has a create app command that can basically bundle everything. So it'll bundle Julia, all your artifacts, and the code that you have written into a sysimage and bundle all of that into a directory which you can just zip and send, right? And that helps a lot in the packaging problem, right? This is even bigger. So, if your sysimage is like 2G, this will be 2.5G with all the, maybe we actually have 8 gigs of bundles for some of our products with, it'll have MKL, which is a gig, and it'll have CUDA, which is another gig. And so these are humongous file sizes, right? One thing to remember as you are using sysimages is relocatability, right? When you have a sysimage, your code is not being loaded from the Julia depot. So it's not being loaded from .julia/packages, right? So any code that has dependencies about where it's loaded from will fail. And so, when sysimages sort of came into being sort of 3-4 years ago, there was a huge effort across the ecosystem to actually go and fix packages that had these assumptions. For example, timezones.jl for a long time didn't work with sysimages because it would load the time zone files from its source code directory, which obviously doesn't exist with a sysimage. So you need to think about, how you're loading stuff. Do you have sort of file paths or global pointers in your module globals? So you need to get rid of all of that and use either init or once per process to handle all of that, right? Right. So sysimages create large binaries, and obviously the solution is to create small binaries, and that is what JuliaC is all about. And JuliaC, there's a whole lots of videos. JuliaCon talks about JuliaC, so I won't go into too much detail. The big thing with JuliaC is that currently we can create binaries which are about 1.5 meg, right? And it'll go down even smaller. The downside is that all the code that you use with JuliaC needs to be statically inferable, right? So you can't use any dynamic dispatch, and that is your code and all your packages code, right? So as I said, when sysimages came in, we went through across the ecosystem of Julia packages to clean things up, to not have any file path dependencies. We now need to do the same across the ecosystem for Julia C, right? Because a lot of packages depend on dynamic dispatch. And so a lot of base has already been cleaned up, but as you start using http.jl, for example, you will find that there is a lot of dynamic dispatch, right? So the key innovation of package compile of Julia C is basically what is called trim support in the compiler, which takes your code, runs your infers your code, and figures out all the dependent functions that you will call from your code, right? And then it removes everything from the standard libraries, from all the dependencies, and just creates a binary with everything that you will actually call, right? And that is in the compiler, but you need some infrastructure around it, and that infrastructure is run using a application called Julia C, which you can add, right? Sorry, yeah. So you can in Julia there's a new command called application add or app add. You say app add Julia C, that gives you a command line on your machine called Julia C, obviously, and you call Julia C on a Julia package. In this case, I'm calling it on a package called hello app, which has one file, and you say output exe, and then you say -trim, right? And that'll trim it, and that creates a small binary called hello. You run it, and that that's about, as I said, 1.5 MB, and it runs. It's a completely standalone binary, right? But when I say standalone, I'm sort of lying a bit, because it actually depends on libjulia, which is sort of the underlying Julia runtime, right? So if you do, if you look at the dependencies of this binary, you will see that it depends on, libjulia.so and libjuliainternal.so, and also all of its dependencies like libunwine, which is a Julia dependency. So you still need this installed at some point in some way, right? Or you need to, somehow get these libraries onto your target machine, right? But Julia C has an option to that. You can do what is called packaging or bundling. So if you say Julia C ---- bundle, that will then actually just put your code, the binary, which is hello, and all the dependencies of Julia, and it'll just create it in a single directory, and everything will be sort of pointed at the relative file path, right? So that's Julia C. How am I doing for time? Okay-ish, I think. Right? Okay, so that's, as I said, there are lots of videos on Julia C on the internet. There is documentation, so, there's a lot to be said about that. But for now, if you have code that is fully inferable, then Julia C is a good option for distributing it. And, there's a lot of work going on to actually make Julia C create sort of embeddable, so, on a low power embeddable machine. And, so people are using Julia C to take Julia code and put it on, a small device, which is, part of a satellite or a car or whatever, right? All of that is being worked on, right? Shifting gears a bit for the last few minutes. If you're running long-running services, web apps, API endpoints, you will do your precompile, you will start your Julia process, but your first request will still hit a function that, have you compiled it or not, right? So you need to worry about what happens when your first request comes in. Does the function that the request runs, has it been precompiled? Is it part of your precompile workload, right? So, I was talking about precompile workload before. This is also one area, if you're running a service, you need to think about it. If if precompile workloads are too complex for you, then you should run warm-up requests, right? Bring your service up, have something hit all your endpoints one by one, and then open it up to your customers or to your clients. If you're running long-running services, you're presumably using HTTP.jl. You need to think about what concurrency style you use, right? Threads or tasks or processes. HTTP.jl can use one or all of them, depending on what your workload actually is, what kind of stability you need. You want to think about that. You need to think about a process manager, something that, Julia processes can crash. So you need to restart them. I would very much recommend not putting HTTP.jl out on the internet, always fronted with, Nginx or Caddy or Apache or some more popular web server, primarily because HTTP.jl is not that well tested for security issues, right? It's not that well used. So, you should pay attention to vulnerabilities. There is a new Julia vulnerability database that you should, follow if you are using HTTP.jl in production, right? Finally, considerations for cloud native usage. If you're deploying to AWS or Azure, there are Julia packages for Azure and AWS that you can use to interact with the services. So, create new machines or secrets. You can do all of that. One thing about running Julia on the cloud is that Julia is generally more memory intensive than Python or Go. And memory is the biggest cost on the cloud, right? CPU is relatively cheap if you compare, with a local cluster versus AWS. CPU pricing is okay for, equivalent amounts of CPU, but memory is much more expensive. So if you're running Julia on the cloud, you have to think carefully about what, the economics of memory on the public cloud, much more than the economics of processors, right? Shared disks are slow again on the cloud, so think about that. Finally, Julia runs pretty well on Kubernetes, and there's a Julia package to manage Kubernetes processes. And I would recommend if you're running it on AWS, on Azure or GCP, try and figure out if you can run your processes on Kubernetes. That'll, make things easier actually. So on that note, questions, let me know. I'll be around for the next week. So happy to, go in more depth about any of these. Yes.
That's great presentation. Thank you so much. Mike's coming. So thank you so much for this great overview. It was really interesting. I have a question about Julia C.
Yeah.
So I have one packages which is essentially data loading packages.
Yeah.
It loads data, and depending on what type of the data is in the file, it returns a single precision or double precision array. So it is inherently type unstable because the type depends on what's on the disk. Yeah. And so I'm considering to provide a separate API, a type stable API, where the user provides, okay, now I'm loading a double precision array. I know it's double precision, so the Julia compiler can infer now what's coming. And would this work with Julia C? So if a package has a type stable, unstable API, but this type unstable API is not exercised within a given program, would this still work with Julia C?
Yes, I believe so. I can't say with 100% certainty, but I am 90% certain it will work, provided that, your precompiled workload, the trimming only happens, based on your precompiled workload. And so when you're trimming, the path that it sees is fully inferable. Okay. It should work, right? Obviously, your users won't be able to call those other functions at runtime, but that should be fine, right? Okay, one thing I should also probably mention here is that there's a lot of I said for Julia C code should be inferable, right? And the immediate question that I asked Jeff immediately was, do you have a list of what it means, right? What is the definition of can you write down how to write code that will actually work? And generally the advice is that if the compiler says it works, right? So they're working a lot on making the error messages better. And so there won't be sort of a cheat sheet of how you write code, but you run the compiler on it, and the compiler will sort of tell you if your code won't compile with Julia C, and you fix it, right? And that's the workflow that people have been working on. There's also Jet actually. So Jet, which is a new sort of static analysis package, and Jet should also tell you not 100%, but to a great degree of certainty whether your code will code is trimmable or not. And so you should run Jet on your package actually. So in your CI, start running Jet on your package, and then then you can keep it going to ensure that your package is Julia C compatible or trim compatible, right?
I have a second question, if I may ask.
Sure.
I'm also interested in cross-compilation.
Yes.
So compiling Julia to WebAssembly or to another architecture, RISC-V, for example. And I use GPU compiler for that. And it works, but it's not a great fit because it's really specific to GPUs.
Yeah.
So is there maybe some time on the roadmap for Julia C to also support cross-compilation?
Yes, there is in the roadmap for Julia C to support cross-compilation. It's I know people are working on it right now, but it's going to be a lot of work, obviously. There's QEMU involved, and I think people are basically building a custom Linux distribution to allow cross-compilation to work. So yes, it's very much on the roadmap. It's being worked on today, but it'll take a while. But from the company perspective, our customers need it, and so we are working on it.
Well, I'll say that the cross-compilation that's kind of been planned is a little bit of a hack, because it's known that the cross-compilation in full is going to be extremely difficult to do, but we do have the binary builder infrastructure, and so what Jameson was proposing and putting out is tying Julia C with binary builder, so that way you can have basically run Julia C on VMs, and that gives you pretty much a good way to do cross-compilation in most systems. So
Yeah. So yeah, not real cross-compilation, but effectively you just get a cluster to build everything for you.
yeah.
Yes, true. But yeah, that's why I'm saying QEMU is involved, because right now Yggdrasil only sort of does it on fixed sort of CPUs, and so the idea with allowing this, because the reason why we want this from our point of view is to, as I said, compile to embedded systems, right? And so part of the work is to ensure that the Yggdrasil ecosystem can work for embedded operating systems and embedded machines, right? Yeah, you had a question.
Yeah, I had a question. Also regarding Julia C, I haven't used it yet, but it sounds amazing that you get it really small. I was wondering whether there is already now, or maybe soon in the future, a possibility for, say you have an application that consists of a couple of packages, and you know that some of the kind of, let's say, the packages further down, that they're static, and you don't actually need to, let's say, it will take a lot of time to compile through them, but you know always exactly the types that go through them, so that's fine. So can you think of an application where you basically have it two-layered, so you have a dynamic at the top, so that you as a developer, you can play around with stuff, but the stuff that you know is not going to change, you can just basically pass that to Julia C, you can compile it, and therefore your playing around is kind of much quicker, because you still have the dynamic stuff at the top, but you have the advantage of the static compiler below.
So the detailed answer to that is probably a question for Jeff or Gabriel. So the one thing I can say that might help is the whole Julia C infrastructure actually is also built to be embedded in Julia. So when you build something with Julia C, there's a hack called --privatize now, where you can load the result back into a Julia runtime, right? So maybe that's something that you can use where, you load it back into so you have something that you compile with Julia C, and then the result you load it back into a Julia REPL that is fully dynamic, right? And so, that kind of mechanism works. Maybe it needs better tooling, but that's one thing I can think of right now.
So what you basically propose ends up being how the actions for how the package binaries end up actually working in the latest iterations, right? So the neat thing is that is how package binaries are working. Now, the reason why you want to do that, though, and the reason why you'd be asking it, though, is you say, oh, but package binaries you can't ship. But if I got this binary, I can potentially build this binary and then ship it to other people, right? That then comes into play with cross-compilation, right? So this is in the story of if we begin to start to have cross-compilation as part of the system, then we can start to think about things like, okay, maybe we build binaries for all these more static packages, like linear algebra packages and such, and we can ship the binaries to everyone. And so that you don't have to pre-compile on your own computer, you just get a binary just like you do for the rest of the binary builder system. But that's the limiting factor there is not the Julia infrastructure on how do I make this so that I can embed it back into Julia. The limiting factor there is all about cross-compilation, because otherwise it's like, if I build it on this Mac, any binary that I get only works on this Mac, and so you need all the ability to get all the different binaries easily.
So Jeff calls this separate compilation, right? And this is very much on his roadmap. It has been on the roadmap for a while, but again, it's a huge amount of work. So that'll happen where, you can basically get a fully statically compiled HTTP.jl that you use, and then everything else is then dynamic, but that'll take a while. Yes.
So a couple of quick questions. One is, when it comes to deploying basically on GitHub through Actions, do you have any specific tips or advice on that?
Not really. I mean, on that Actions, you do whatever works. I don't think there's any major thing. The only important thing, I guess, is to set up caches correctly, because that'll save you a lot of time in downloading and recompiling or precompiling every time. So the critical thing, I guess, is to set up caches so that once you precompile, you have your depot, you can reuse your depot from one run to another, because that takes a while. Chris might have more tips about.
Your depot won't actually be the same between the different Julia versions. But one
No.
of the things that can help you, the biggest thing that can help you is, so Julia or GitHub Actions, their default runners are always going to give you a blank runner each time. So even if you use like a lot of the caching things, there's so many different architectures and stuff you can end up getting in the cloud that they basically have to just say have to be pessimistic and throw out too much of the caches. If you allow yourself to set up just like a simple like for server or something as like an internal node, it will actually cache very well. So you'll see like a lot of your tests will suddenly run in like 30 seconds or 3 minutes or something, because it can keep a lot of the binaries between them. If you're doing things like PRs that are then only adding new tests or adding new benchmarks or something, it'll actually be completely cached already, because if you just make it so that way it shares the binary caches. So I'd recommend in that scenario the actual thing to do is just not rely on GitHub Action servers, because the way they do the containerization is actually looking at scaling caches, not necessarily the rest.
All right, I guess I'll follow up with you on that to try and understand how to do this.
I can show you. I can show you what we ended up doing for ordinary DQQ, because like ordinary DQQ has 96 different tests that are run, and we had to make it so that way we cut out the pre-compilation. We only pre-compile once, and that's how we got it.
Great, thanks. So my other question was about the Pluto package that I was surprised not to hear about, given that they were one of their innovation was to include the project and manifest toml in the file. I'm wondering why, or I guess to what degree, is Julia Hub sort of promoting and supporting Pluto, or is it a bad idea, or should I forget about it?
No, Pluto is a great idea. But Pluto has nothing much to do with Julia Hub. It's run pretty independently. We support Pluto on our platform, so on Julia Hub itself, we can run Pluto, but Fons sort of is pretty independent in doing maintaining Pluto. A lot, as you were saying, a lot of ideas from Pluto are being populated into other areas. This project and manifest in the file is obviously something Pluto started doing. That is now in PKG. I'm not certain if the two are sort of compatible, or they'll use one or the other. I don't know. That's again a question probably for Fons or Panayotis. But yeah, I mean, Pluto's ideas are obviously being used elsewhere. Malt, which Pluto started, is also something that we use at Julia Hub now as well, to run distributed code. Malt is actually pretty great, even though I didn't talk about it. But it's a little bit of a detail, I think. But yeah, so Pluto's done a lot of great stuff, and people are using it, but I don't know anything beyond that. Just see what Fons does and follow what he does. I think that's the message, I guess.
Fair enough. Thank you for a great talk.
Thank you.
We have a question here on. Okay, so the question that we have online is: does using Nix PKGs as a tool be useful in case of cross compilation? I believe it has a concept of build platform and host platform.
I don't believe so. I don't know much about Nix. I don't use it, but I know a lot of people who love it. But I don't think it'll help with cross compilation as far as I know, but that's just a very vague answer. Chris is smiling, so I think he has something to say.
Well, I'll say that there are very many.
I
don't know. Maybe I don't want the mic for this. Nix's package management and stuff has always kind of generally given more complicated Julia packages a bit more issues, because they have different Julia build and certain things like that. So while Nix has some very great ideas, I do find that on the more complicated projects it hasn't really panned out so well. And so I wouldn't be so keen to be trying the next Nix thing, but they do have some very good ideas that we need to be pulling into our infrastructure and such. That's, I guess, how I'll say it.
Thanks, Chris. There's a question here in front, I think. Are we okay with time?
Hi.
Yeah.
Thank you. Awesome presentation. I wanted to ask you, I have a little experience working with deploying Julia within a Docker container. And one of the things you mentioned with the memory hints was really useful, because I have experienced some weird behaviors, and I think this explains it quite a bit. I have not thought about this. So thank you for that. So my question is, I've noticed that Julia can be quite intensive in size of the container.
Yes.
And also memory utilization. And I was wondering if Julia C, it might be helpful to reduce the size of the container.
Yes.
And also the memory.
Yes. So absolutely. So like we run containers which are like 8 gigs, right? And it takes 30 seconds to even download it from the AWS container registry to the node, right? And that's 30 seconds of latency that you lose in every request. So that's a problem, yes. And Julia C will help, but I am not certain it will help anytime soon, because the reason why our containers are 8 gigs is that it basically downloads the world, right? It has maybe dependency on 1,000 packages, right? And getting all of those packages to be Trim compatible is going to take at least a couple of years. So, so yes, once the ecosystem is more robust in terms of Trim compatible packages, absolutely it'll help, but not, in the next few months, I think. In terms of memory, I don't think so. I think Julia's, the one thing that, sort of blows memory out is, of course, BLAST. So setting BLAST threads is one important thing in terms of, keeping your memory in check. But beyond that, the Julia compiler itself uses a little bit of memory, but not too much. So maybe there'll be some changes at the margin. My gut feel is that it won't change too much. Most Julia code that uses a lot of memory generally is just because it's doing stuff, right? And it'll keep doing stuff. It does a lot of work, and so it needs memory. So I'm not sure that Julia C will help very much with memory, but certainly on image size, it'll help once, the ecosystem is a bit more trim compatible, right? So I don't know if that answers your question, but I mean, it's feelings at this point,
Yeah,
right?
you did. Thank you. Another question
Sure.
is, do you know any tips on maybe we cannot mess with the memory footprint on the Julia application itself, but do you know any tricks of maybe changing some of the parameters when building a Docker container or deploying in a Docker container, changing the memory parameters? Any tips on tricks on that to reduce a little bit the memory intensity of a Julia application?
No, I'm not sure, immediately if I can say much. As I said, the BLAS threads makes a big difference, right? I think the default BLAS threads are set to large, like 64 or something, and you don't really need that in a Docker container. And the memory that the BLAS uses is proportional to the number of threads that you use. So reducing the number of BLAS threads is something quite immediate that can reduce it. Beyond that, I don't know. If I think about something, I'll let you know.
Okay. Thank you very much.
Thanks. Thank you. Thanks a lot.